Welcome to our electric circuit analysis series. Today we're going to talk about charge and current. Charge is an electrical property of atomic particles. Protons have a positive charge and electrons have a negative charge. The symbol for charge is Q. Charge is measured in coulombs. Therefore, 1 coulomb is the basic unit of charge. The symbol for coulomb is C. The charge contained in a single electron is negative 1.602 times 10 to the power of negative 19 coulombs, while 1 coulomb contains 6.24 times 10 to the power of 18 electrons. This means that in a single electron there is a very tiny amount of charge. We can rewrite this as negative 0.0000000000000000. That's actually 18 zeros followed by 1602 coulombs of charge. That is a very small amount of charge. On the other hand, in 1 unit of charge, meaning 1 coulomb, there are very many electrons. We can rewrite this as 624 followed by 16 zeros. 0.0000000000000000. And this is how many electrons there are in 1 coulomb, which is a very large quantity of electrons. The formula for charge is Q equals N times E. N stands for the number of electrons, and E stands for the electronic charge per electron, which again is negative 1.602 times 10 to the power of negative 19C. The electronic charge contained in a single proton is the same magnitude as that of an electron, but with a positive value. So positive 1.602 times 10 to the power of negative 19 coulombs. And we can find the amount of charge contained in any number of protons using this formula, N times P. So now let's talk about current. What creates electric current in an electric circuit? Here we have a very basic circuit containing a voltage source and a resistor. Current is created when positive charges move in one direction while negative charges move in the opposite direction. This motion of positive and negative charges is what creates electric current. The conventional direction of a current is the flow from the positive terminal of a power source to the negative terminal of the power source. This is the same direction that positive charges flow. Electrons, on the other hand, flow from the negative terminal to the positive terminal of a power source, so they flow in the exact opposite direction of the flow of positive charges. So when we talk about current, we will actually be referring to the flow of positive charges. This is known, again, as the conventional direction of current flow, the flow of charges from the positive terminal to the negative terminal of a power source. Current is a time rate of change of charge. The symbol for current is I. It is equal to the change of charge per unit time. Substituting Q with NE from our earlier formula gives us dN over dt times E, since E is a constant number. So we can just pull it out in front of the derivative of the number of electrons with respect to time. Current is measured in amperes. The symbol for amperes, also called amps, is A. Therefore, 1 ampere, or 1 amp, is equivalent to 1 coulomb per second. Current is really the amount of charge that flows through a particular point in a circuit. So if we take any point in a circuit, then the current is equal to the amount of charge that passes through that point per second. Now, if we take this formula for current, we can derive the formula for charge, which is equal to the integral of the current multiplied by dt, which is the change in time measured in seconds, integrated from some initial time to some final time. So we can find the amount of charge that has flowed through some particular point of a circuit by integrating the current that has flowed through that point over a certain period of time. Notice that this formula is comprised of a definite integral, denoting a specific initial time as well as a specific final time. However, if we are not given the specific time period, then we can use this formula, which includes an indefinite integral of the current, as well as an initial charge, which we can determine by using a given initial condition. For the purposes of this tutorial, we will be referring to current as direct current, also known as DC current, which is current that flows only in one direction. Alternating current, on the other hand, flows in both directions and changes direction with respect to time. We will cover AC current later on in this electrical circuit analysis series. This lecture is included in Unit 1 of our electric circuit analysis series, where we cover basic concepts including charge and current, voltage, and power and energy. The formula sheet for this entire unit is available for purchase at payhip.com/EngineerPeer. Right now, all our formula sheets are on sale for 50% off.